Um, so we're recording now. Okay. And so this is roughly what your data table should look like. Um, the mass of the empty box that stays same through the whole way through, right? Remember, we were filling up that box with water, and then we were finding the mass of the box with water. Well, this was the mass of the box without any water in it, so that's not going to change. Um, Similarly, the inside length and width of the box, that's not going to change. Right, the only thing that's changing is the inside height, the water level inside the box. Um, okay, so and then just real quick, uh, I mean, to calculate the mass of the water in the box, we're just subtracting. Um, for example, we would subtract these two to get 12.34. That's just 31.5 grams minus 19.16 grams. And that will give us 12.34 grams. Is everyone good on how we calculated the mass of the water inside the box? We're just subtracting these two values.
Do we have to fill these boxes out like with objects we have at home?
Can you ask that again?
Do we have to fill these boxes with like the measurements of the objects that we have at home, or is there something specific you want us to measure?
No, you're supposed to watch the Ed Puzzle videos, Sabrine.
Oh,
Yeah, some of you are not watching my lessons. You got to start doing that. Especially on lab days. Like, you guys are learning this from home. You don't have the materials to do any of these labs at home for the most part. Um, if you are going to do it at home, I'll give you like some specialized instructions for doing it at home. But just in general, when I give you a lab, I've filmed the lab at school, and then you're supposed to watch me do the lab, and that's going to help you fill out the data. So, Sabrin, that's where I would start for you for getting this data is watching the lab. So it's in uh, uh, Tuesday's folder for this class. Okay, Tuesday of week 3. Okay, so then let's do one more calculation. I'm going to show you how to calculate the volume. To do the volume, we're just going to be, I'm going to do this in blue. We're just going to be multiplying these three values together. And so then I'm just going to erase up top here. So like for this one, we're taking 5.4 times 5.4. Oh, and that's centimeters. Centimeters. Um, Centimeters and 0.5 centimeters. And then we multiply them out. So 5.4 times 5.4 times 0.5. And that gets us to 14.58 centimeters cubed. Okay. So you need to do that for each column. So you're going to be subtracting these two values to get the mass of the water inside the box. And you're going to be multiplying these three values to get the volume of water inside the box. Does anybody have any questions on how I'm calculating those? Okay, then we're going to move on. So graph number one, mass of water versus volume of water. So for this one, go ahead and type in the chat, which variable do you think I'm going to put on the y-axis? Is it going to be the mass or the volume of the water? Go ahead and type that in the chat. Okay, good. Yep. So remember that whenever we do these graphs, the title is always in the form of y versus x. So here, I'm going to do that in purple right here. So y, actually, I'm going to do it like this. So y versus x. So then on the side here, this is my mass. Okay, I got to go jump to another breakout session here real quick. So I'll be right back. Okay, so let's try this one more time. This is going to be y versus x. And so we're going to put mass on the y-axis. Oh man, that was terrible. Let's try that one more time. And don't forget to include the gram sign. And then on the x-axis, we'll do the volume of water. On this axis, we should include volume.
Will there be like a retake for this? I did this wrong.
You can resubmit it. I haven't graded them yet.
Oh, okay.
Yeah, so if you are seeing this part and you're not understanding it, or you didn't think you understood it the first time, I should say, yeah, just redo it. I haven't graded any of these yet. Okay, so that's how we should be graphing it. So then where are we getting what we should be graphing from? Well, that comes from the table, and I color coded it to help you out. So mass of water in grams, that's the blue column. So here, I'm going to stop annotating. Massive column in grams, that's the blue column. So to get your Y data, oh, okay, I got you. Shahid, you are present. So you're going to be plotting the blue data. Those are going to be your X values, and then the red data, that's going to be your Y values for this first graph. So look at the blue column for your, oh, sorry, I might have said that backwards. Look at your blue data for your Y values and your red data for your X values. And then it's the same deal for this next graph. For this one, we're going to look at the green column and the red column. So the green column is going to be our Y data. The red column is going to be our X data. And we're just going to plot the points and make the graph like we've been doing. All the things need to be there, need to have axis titles. Your scale needs to be good so that it uses the whole graph. It needs to count by consistent numbers. You need to plot your data. You need to have a best fit line. All of the usual stuff. So first of all, number 6 had a typo. It said, what do the data in graph 1? It should have said graph 2. So change that to graph 2 in your assignment. So discussion questions 1 through 4, that's all stuff that we've been doing. You're just going to use your graph to try to answer those 4 questions. So draw the line, from the axes to your best fit line, and then from the best fit line to the other axes to get your estimates. What do the data in graph 1 tell you about the relationship between the mass and volume of water? The mass of water in grams is, and so what do we think? Go ahead and type in the chat. The mass of water in grams is much larger than, much smaller than, or about the same as the volume of water in milliliters. Shahid says same. What do other people think? Oh, yep, about the same. Okay. Seem to be in consensus about that. So here, I don't have the graphs, but let's take a look at the table. When we look at the table, what we should see is that our volume in milliliters is almost the same as our mass. Let's just compare a few values. 34.8 to 33.46, 24.5 to 23.40, 13 to 12.34, 36.2 to 34.79, 63.6 to 62.2, 51.4, 59.60. So this is because 1 gram of water equals 1 milliliter. Our metric system unit for mass, the gram, is based off of 1 milliliter of water. Right, when they invented the gram, when they came up with that, what they did was they took a milliliter container and they filled it up with water, and then they found the mass of that container, and that became the gram. Okay, so then how about data table 2? What does that tell you about the relationship? Oh, wow, did I not change anything? Data table 2 was supposed to ask, man, I didn't change this question at all. Huh. You guys can skip question 6 because I did a bad job of writing it. So you can go ahead and cross that out. I'm not going to be grading that. I'm just going to grade you on questions 1 through 5. Does anybody have any questions about the lab?
So are graphs always y versus x? Is that just a consistent thing?
For the title, yes.
Okay. What about for the graph itself?
Well, y and x are just where you put them on the graph, but here, let me explain it.
I did mass of water on my x-axis for the first one. Is that wrong?
It is because the title is always y versus x. So for that reason, whichever one comes first needs to go on the y-axis. If I didn't give you the title, then maybe you could have done it any way that you wanted.
Oh.
But because I gave you the title, that was like supposed to be like your hint that this goes on the y-axis. But if you did it different the first time, that's okay. Just make corrections and redo your graph.
So the one that comes first is always going to be on the y-axis?
Right, if I give you a title.
Okay.
That's kind of a new thing. That's the first time I've done it like that, where I give you the title and then you're supposed to know from that which one goes on Y, which one goes on X. You could also use the table though to get that. Remember that the variable that's on the left is always X and the variable that's on the right is always Y, or at least usually when you set up your table. So red is X, blue is Y. Well, that's the same thing as in the graph, right? Red is X, blue is Y. Does that make sense, Meg?
Yeah.
And then
Oh, I get it. Okay.
yep. And then it's the
Yeah.
same thing with the third graph. So this one's on the right, so this is your X. This one's on your left, so this one's your Y. And that should be consistent with how I did the graph title. So this one's X and this one's Y. I put the title in and color coded it so that you guys would be more likely to get that right. But if you didn't, that's okay. You can still make corrections because I haven't graded it yet.
Okay. So just to make sure, the volume of water, the green one, is gonna be on the y-axis too?
Correct.
Okay.
Good. That was a great question, Meg. Does anybody else have a question? Okay. Well, if you haven't turned these in yet, get them in. These are summative. This should be your first priority for today is to get this looking good and turn it in. Remember, you can cross out question 6. You don't have to do that. After that, there is a Hershey Bar Lab. It's just meant to be kind of fun. It's formative, so it's not, going to have a huge effect on your grade. So if you don't get to it today, I know a lot of you are kind of behind on assignments. Don't worry about it. If you are caught up on assignments, get it in, because I mean it is worth points. But like just in general, I would focus on getting that volume and mass lab in first, just because it's summative, so it's worth a lot bigger percentage of your grade. And in fact, this is going to be your only assignment in that summative category so far. That's your summative labs and projects category. So really, this assignment at this point is worth 30% of your total grade. So you want to make sure that you get it in. With that, though, we've got 20 minutes left in class, so that time is yours. Use it wisely. If you have any questions, stick around, and I will try to answer them. Otherwise, have a good day. Brianna, do you have a question?